Welcome to another video. Today we're going to go over how to solve quadratic equations that are factorable and equations where a value is 1. We'll go over 3 different scenarios, and when you start these equations, the very first thing that you have to make sure to do is to put it in standard form, which looks like this, where your a value is the number next to whatever your variable squared is, b is the one next to the x, and c is just a constant. Thing I want to mention too is that it's not always going to be x. Sometimes the variables change, but it's pretty much the same steps. So let's just get started. First thing you want to make sure is that this is in standard form. So easy way to put this is to make sure that all your equations equal 0, which is not the case right now. So we just got to get rid of this negative 15, throw it on the other side by adding a 15 to both sides, and we get this n squared plus 8n plus 15 equals 0. This will only work when this a value, the one next to the variable squared, is 1, because if it's not 1, then you're kind of screwed. Just kidding, you're not screwed, there's just more steps, and I will go over that in another video. If this is factorable, here's how you set it up. This is my favorite way. There's a graphic organizer that I use. You want to come up with 2 numbers that multiply to a times c. And in this scenario, a is 1, c is 15, so 1 times 15 is 15. And the same 2 numbers have to add up to your b term. And in this scenario, our b term is 8. So in these blanks right here, it has to be the same 2 numbers that satisfies both of these conditions. 2 numbers that multiply to 15, think of factors of 15. 1 and 15 does multiply to 15, but those same 2 numbers won't add up to 8, so that's not going to work. And the only other factor is 5 and 3. These 2 numbers have to be the same. When you use this graphic organizer, probably the hardest part of the problem, and once you have that, since it satisfies both of these conditions, then we just have to write it in its factored form. N plus 5, which is that first number, and n plus 3, which is the second number, equals 0. And from here, once it's factored, we just have to set up 2 equations. N plus 5 equals 0, and n plus 3 equals 0. Solve for n by getting that by itself, and we get n equals negative 5, and n equals negative 3. Those are your 2 solutions, and if you wanted to check, you can substitute that for n, and this will make a true statement. But I also want you to have another resource besides plugging it in. If you type this onto Desmos, I would just type the one in standard form. The only thing is, on Desmos, you can't type in n squared, it won't graph. So just change your n's to x's, just like that. You don't have to put equals 0. It will graph what that quadratic equation looks like, and these 2 points right here are your solutions, which are the same solutions that we got, negative 5 and negative 3. Those are your zeros, your solutions. They also call it your roots. Moving on to the second equation. This looks somewhat difficult, but it's not that bad. All right, first thing again, make sure that this is in standard form. So you don't want these terms right here. You want to bring them to the other side by just doing the opposite. Add 3, and when you add the 3 here, make sure you do it to the one that's like terms with it. You're going to add 3 to that. Might as well do 2 things at the same time. Get rid of the negative 5k squared by adding 5k squared, which matches this term right here. All right, add it up, combine like terms, and we get 1k squared, or just k squared, minus 8k, and negative 3 plus 3 cancels out. It equals 0, which looks a little confusing right now because the c term is missing. But when that happens, it's actually a lot easier to factor this. When you have your a and b term right here, all you have to look at are these terms' greatest common factors. Starting with a number, the greatest common factor of 1 and negative 8 is just 1. But out of these 2 terms, they have a common k factor, which we can factor on the outside. And if I take a k out, it's kind of like reverse distributive property. Whatever you took out, you divide these terms by it, you will be left with k minus 8 equals 0. So believe it or not, that is already factored. And once it's separated into 2 pieces like this, you just have to take each piece and set it equal to 0. K equals 0 and k minus 8 equals 0. Here's one solution already, but in the other one, we just have to solve for k. and we get k equals 8. And as I mentioned, just change your variables from k to x. So if I type that in, x squared minus 8x, you will get your two roots. One is at 0 and one is at 8, which were our two solutions. To do a lot of these, you get used to it. It'll become easier like anything else. Put this bad boy into standard form by adding a 7, and we get this. And you're probably thinking, well, this looks a little different because my a term is not 1. So in this last question, this will teach you to always do this step. If this a term is not 1, always check if all these terms have a common factor, which they do. They have a common factor of 7 because all of these are divisible by 7. So that's what we're going to write on the outside, and you're going to be left with r squared minus 2r plus 1. Once you've done that, all we have to do is factor this part. So you're going to come up with two numbers that multiply to AC, which is 1, and it's the same two numbers that add up to -2, your b term. Students always get confused with this because they always just put 1 times 1 is the only factor of 1, but 1 plus 1 does not equal -2. So don't forget that you can always use negative numbers too, because -1 times -1, two negative numbers, multiply to a positive result, and -1 plus -1 equals -2. These are what we're going to use in its factored form. It's going to look like this: r minus 1 times r minus 1. The same factors equals 0. If you're wondering what happens to that 7, it just slides right down. And in this scenario, we only have to solve one of the factors. We only have to set one of those equal to 0, since these two will produce the same result. Solve for r, and we will get our value of r equals 1. If you graph this onto Desmos, just replace the r's with x's, you will see that that graph only has one root, one solution, 1, 0, which matches our answer 1. So that parabola is not always going to touch the x-axis twice. It will get harder from here, but hopefully all that made sense. If it did, like and subscribe, and I'll see you on the next episode. Peace.